Hi there, Mr. Sutton here, bringing you the AB Calculus 4.1 Extra Practice Number 2 solutions on extreme values of functions. On this calculator-based problem, we're trying to find the absolute max and min on this interval. So we're going to start by figuring out what the critical values are, taking the derivative of this thing. So for the derivative, I'm going to need the product rule on this one. That's u prime v plus uv prime. So let me set up a box and ribbon to help me with that. I have my factors, e to the x, and this polynomial here, x squared minus 5x plus 7. And the derivatives of those are going to be e to the x and 2x minus 5. All right, multiplying all this out, we have e to the x times the upper right here, plus e to the x times 2x minus 5. So this is my f prime. And since this is a calculator problem, I'm just going to see what this equals to make this all come out to 0. So I'll set it equal and solve this on the calculator now. So here I am in my calculator, in my y equals, and I actually took some time off camera to enter a few things. In y1, I put the original function because I know I'm going to need to plug things into that to test for the absolute min and max using the candidates test in a little bit. And in y2, I put this derivative that I just found. All right, so let me actually go back and let me deselect y1 because I don't want to graph that. Just want to graph y2, f prime. Now let me pick my window. And my window, I'm going to go from -1 to 3 because I'm really not concerned with critical values that don't fall on the interval here. So we go -1, +3 is the other value. Oops, go back. +3, there we go. And now let me do zoom 0, zoom fit, and let's see what this thing looks like. All right, so there's my f prime, and it looks like we're crossing in two different spots. Let's find out what they are. So we've got, let's see, second trace, option 2. For my left bound, let me click a little bit to the left here. Right bound, a little bit to the right. Enter one more time. And it looks like 1 is one of our intersection points for the x-axis. And the other one looks like 2, but let's just be sure. So let me do second trace again. Option 2. Move a little bit to the right now. Enter. Move a little bit further to the right. Move my spider above the axis. Enter. Enter one more time. And, yep, x equals 2 is the other one. All right. So this gives us four candidates for the absolute max and min. We have the two critical values, 1 and 2, which are both on this interval here. We also have the endpoints we have to test, -1 and 3. So let's test all those. The first thing I'm going to test is -1, and I test all of these by just simply plugging them into the original function. So f of 1, let's go back to the calculator for that. Let me quit out of my graph, and I'm going to do alpha trace and pull up my y menu. y1, let's open a parentheses here and put -1 in there. Close the parentheses if you want. And then if we press enter on that, that's about 4.782. Which, I mean, we need to look at all the candidates before we can tell if this is a max or a min, if anything. All right, let's check out, what's the next one here? 1, f of 1. So going back here, I'm going to yank my input from before, and I'm just going to delete the little negative now, so I've got +1, about 8.155. Next, let's check out f of 2. Going back, input from before, let me replace the 1 with a 2, and that's about 7.389. And then finally, we have f of 3, the other endpoint, our last candidate. Going back up, let me get that input again, plug in 3 instead of 2, about 20.086. Well, that's quite an increase there. So taking a look at all of these, it looks like out of all of these, 4.782 is the absolute min, and by a long shot, 20.086 is the absolute max. For this problem, I'm trying to find absolute min and max for this polynomial on the interval from -1 to 3. I'm going to start by getting critical values. So for that, I take the derivative, which is going to be -4x plus 4, and I'm going to set that equal to 0. So that's going to show me my possible direction changes, possible mins and maxes. So setting that equal to 0, if I subtract 4 and divide by -4, I get an x value of 1. And that's on the interval, so we're going to have to test it here. So now with the candidates test, we're going to try out our critical value of 1, along with the endpoints, which we always have to try, -1 and +3 in this case. So doing f of -1, that's going to be -2 times -1 squared, so -2 then, minus 4, plus 4, and those 4s are going to cancel. So this is a value of -2. Next, we test out f of 1, the critical value. So that one we've got just -2 plus 4, which is 2, plus another 4, which comes out to 6. And then finally, we test the last endpoint, 3. So that's -2 times 9, so -18, plus 12 plus 4. So -18 plus 16 is going to give us -2. So we see here that we have an absolute min of -2, and there's actually a tie. So you can have more than one absolute extrema as long as they're the same value. So absolute min's at -2, and then kind of by default, because it's the only other number, 6 is going to be our absolute max. To find the absolute min and max for this rational function on this interval, I'm going to start by getting critical values, and for that I need the first derivative. Before I even do that though, let me rewrite this as x squared minus 1 quantity to the -1. That'll make it a little easier for me to use my power rule. Now this is going to be a chain rule. We have something to the -1. Derivative of that is going to be negative something to the -2. So that's -x squared minus 1 to the -2 times the derivative of the inner function. So that's going to be multiplied by the derivative of x squared minus 1, which is 2x. And I'm actually going to rewrite this just so I can solve it a little bit more easily, because in a moment I'm going to set this equal to 0. So I can write this as 2x over x squared minus 1 to the second power, all of that in a negative fraction. So now, setting this equal to 0 and solving for critical values, I see that this is going to equal 0 wherever the numerator 2x equals 0. So that's going to happen at x equals 0. And for critical values, we also have to look out for things that make the derivative undefined. So our f prime here does not exist wherever this numerator equals 0, and that happens at the values of positive and -1. So taking a look at our critical values, we've got positive and -1. We've got 0, so that's potentially 3 things we might have to plug in. Except if you look at the interval that they gave us, 2 to 3, we don't have any critical values on that interval. But we still have to test out the 2 candidates that are the endpoints, so we have to test out 2 and 3 in the original function. But it's just down to these 2 candidates. Okay, so let's do this. Let's plug in 2 to start off with. Now we're using the original function, so this is 1 over 2 squared minus 1. That's 1 over 4 minus 1, or 1/3. Next, plugging in 3, that's going to be 1 over 9 minus 1, so 1 over 8. And between the two of these, 1/8 is smaller, so that's going to be our absolute max, or min rather. And then the bigger one, 1/3, is going to be our absolute max. For this one, we're trying to find the absolute min and max on this polynomial over the interval from 0 to 3. So first, let's get some critical values by taking the first derivative. That's going to be -2x plus 3. And we want to know where this equals 0. We don't have to really worry about undefined because it's a line. It's defined everywhere. So this is going to equal 0. Let's see here. If we subtract 3, divide by -2 at 3/2. And 3/2 is on the interval from 0 to 3. So we do have to test that along with the 2 endpoints for our candidates test. So let's go ahead and do that test now. So I'm going to test out f of 0 to start with. And that's just going to be -0 squared plus 3 times 0, which comes out to a value of 0. Next, testing out 3/2. This is going to be a little trickier So that's going to be negative 9 over 4 plus, let's see, 3 times 3 halves is 9 halves. And what's that add up to? Well, this is negative 9 fourths plus 18 fourths, which is positive 9 fourths. All right. So now let's test out the last thing here, the other endpoint, 3, f of 3. So that's going to be negative 9 plus 9, which comes out to 0. So it looks like there's a tie for the absolute min. We have 0 and 0, so those are both absolute mins. And the other one, which is bigger than the zeros, is the 9 fourths, so that is the absolute max. On this problem, we're trying to find the absolute max and min for this rational function. So we know for sure we're going to have to test out the endpoints here, 2 and 6, using the candidates test. But let's see if there's any other critical values. So to figure that out, we need to take the derivative. And before I do that, let me just rewrite this with a negative exponent. So negative 10 times parentheses x squared plus 5 to the negative 1 power. And now using the power rule and a chain rule on this one, we basically have negative 10 times something to the negative 1. Well, derivative of that is going to be 10 times the something to the negative 2, the something being the x squared plus 5. But wait, we have to multiply by the derivative of the inner function as well. So we'll multiply that by 2x. All right, let me rewrite this a little bit. So we have 10 times 2x, which is 20x, and that's all going to be over x squared plus 5 quantity squared. Now we need to know where this equals either 0 or is not defined. Well, a fraction equals 0 wherever the numerator equals 0. 20x equals 0 at x equals 0. And in terms of things that make the denominator 0, well, you've got x squared, which is always going to be 0 or positive. You've got plus 5, so this denominator is never going to come out to 0. Now, the 0 that we just got, that critical value, that's actually not on the interval from 2 to 6. So it turns out there are no critical values on our interval, which means the only two things we have to test are the two endpoints themselves. So let's go ahead and test those. So we've got f of 2 that we're going to test out first. Plugging that in the original here, that's going to be, let's see, 10 over 2 squared plus 5, so 10 over 9, negative. And we also have to test out 6. So going back here, we've got 36 plus 5, that's 41. So negative 10 over 41. Now, between these things, which one's bigger, which one is smaller? Well, 10 ninths in general is a larger fraction than 10 41ths, because you've got a smaller denominator, but it's negative, so that means this is more negative than this one. So the absolute min then is going to be negative 10 over 9. And that makes this other one the absolute max.